Good morning. I am Devasena. In this lecture, we are going to discuss about two-port networks and introduction. This topic is present in the subject Circuit Analysis under the unit two-port networks. Let's start discussing about an introduction to the two-port networks. A pair of terminals at which an electrical signal may enter or leave a network is called a port. The terminals or port is required for connecting input excitation to the network. It is also required for connecting some other networks such as load. The terminals are most useful for making measurements. In general, minimum number of terminals required is 2. Let's see the type of networks. This is a one-port network. A network having only one pair of terminals or one port is called one-port network. Figure A shows a one-port network. And this is the representation of a network. Here we have one pair of terminal 1 dash. This is connected to the network. Now let's see two-port network. A network consisting two pairs of terminals is called a two-port network as shown in figure B. This is the representation of a two-port network. Here we are having two pairs of terminals. The pair of terminals are 1 dash and 2 dash. The terminals are generally named as 1 dash and 2 dash. In general, a port designated 1 dash is connected to the driving energy source, while the other port designated 2 dash is connected to the load. A port at which energy source is connected is called driving point of the network or input port. Here, a port 1 dash is represented as input port. A port at which load is connected is called output port. Here, the port 2 dash is called as output port. Let's see multi-port networks. Figure C represents a network with n port called n-port network. This is the representation of multi-port network. In such networks, generally one port is connected to the energy source, another port is connected to the load, and other ports may be connected to the different networks. It is indicated in the diagram. Two-port network parameters, that is terminal characteristics of network. A two-port network consists of two ports, that is pair of terminals with two terminals on each port. Consider such a two-port network as shown in figure A. This is the representation of a two-port network with standard positive port voltages and currents. In general, port 1 is referred as input port with port variables V1 and I1. Similarly, port 2 is referred as output port with port variables V2 and I2. Note that the voltages V1 and V2 are shown with standard positive reference polarities. Similarly, both the port currents are entering into the network, hence both are with positive directions. Thus, in all, there are four variables, namely V1, V2, I1 and I2. Any two-port network can be described with these four variables. The network can be treated as a black box for the analysis without knowing network details if all these variables are known. Before starting analysis of two-port network, it is necessary to assume following. The voltages and the current in the actual network inside the box are not available for the measurements. In other words, the measurements can be made on a box containing network using only port variables. The network inside the box is assumed to consist only the linear elements. Also, the network may consist dependent sources, but independent sources are not allowed. If the network consists energy storing elements such as inductor and capacitor, then the initial condition on them is assumed to be 0. Assuming the variables at the input and output ports as transformed quantities. The voltage and the current at input terminals are V1 and I1, while at the output terminals are V2 and I2 as shown in figure A. Now, this is the representation of a two-port network with input ports and output ports. The input port is having the variables V1 and I1, while the output port is having the variables V2 and I2. This is indicated here. In order to describe the relationship between port voltages and currents, one requires the linear equations equal to the number of ports. So, in two-port network analysis, we will require two linear equations in terms of four above mentioned variables. We can obtain these equations by considering two variables as dependent variables while other as independent variables. As the network consists only linear elements, the linear relationships can be obtained by writing two variables in terms of other two variables. There are 6 possible ways of selecting two independent variables out of 4 variables. Thus, there are 6 different pairs of equations defining their own set of parameters such as impedance, admittance, hybrid, inverse hybrid, transmission and inverse transmission parameters. In the further classes, we are going to discuss about these parameters in details.